Hey guys, welcome to day 5. Calculus is in session. For today, I decided rather than continuing to talk about domain and range, which is our next topic, I thought it would be a good idea to take a step back. Because depending upon what classes you took last year, you may not know about something that's assumed to be known in calculus and is therefore not talked about at all in the book except as fact. And so for today, we're going to actually talk about something called interval notation and set notation. These are ways of writing your answers in proper mathematical language. And so when you give an answer in mathematics, most of the time you're trained by teachers who don't do proper math, meaning they don't talk in the language of math. They're used to talking in the language of what's called the layman, the everyday person. And you know what? That's fine. If you don't plan on going any deeper into math, if calculus is your stopping point, then awesome. You don't need to know things like set and interval notation. But if you plan on going farther, set and interval notation is a huge tool that everybody just assumes you should know, which is a shame. Because quite frankly, set and interval notation is really basic, but it's got some nuance to it. And if you're not prepared for it, it can make it really hard to understand something like domain and range and why the answer may be written one way versus not the other way. And so I want to take some time today. There'll be no homework tonight. I just wanted to give a little brief mini lesson on set and interval notation in case you'd never seen it before. And so we'll be doing that today, and then tomorrow we'll get into domain and range, and we'll talk about graphing on Thursday. Okay, so let's get started. So, as far as we're talking about today, the big terms today we're going to separate into two categories: set notation and interval notation. Now, if you have already turned this stuff before, like you've already talked about in other classes, that's great. Use that. Get the answers quickly and move on. There's no homework tonight, so just make sure you agree that this is what the answer should be. But in reality, these two are very similar, but in mathematics, you have to know how to write them or it just seems funky. Okay? So let's start by looking at what an example of set notation looks like. So what an example of set notation would look like is a symbol, like this fancy script R. What this means is all real numbers. So this is what I'm going to call the average, or maybe normal. So we'll look at these in three different ways. So capital R means all real numbers. And so an example of all real numbers would be like the domain of a linear function, meaning every number can be put into it. Now you can put in a 5, you can put in a -3, you can put a fraction, you can put a decimal, you can put a radical. All of them can be plugged in. In interval notation, that same information is written in a different way. Now, in interval notation, it should be noted that in each interval there are a couple key characteristics. The first thing is if it says A, B, bracket. What this means is A is the lowest value, and because of the parentheses, it's not included. Whereas over here, the B indicates the highest value, and it is included. So in interval notation, parenthesis means not included, and it works either way. And bracket means it is included. So for example, if I made the notation such as, let's say, I said -3, 5, bracket. In real words, what this means is all numbers between -3 and 5, not including -3. So this statement in interval notation just means from -3 to +5, not including -3. So therefore, it would include 5 is included. Notice how this takes up a full big sentence. By comparison, this is much lighter and easier to work with. Interval notation is big this way. Now, in set notation, we'd write it a different way. We might say something like, and there's another way to write this in set notation as well, from -infinity to +infinity. Now, if you write it in this form, in set notation, you might something like -3 to 5. These two are equivalent statements, meaning that -3 is the lowest possible number, 5 is the highest possible number. We do not include the -3, but we do include the 5. And so this is set versus interval notation. It's designed to convey a lot of information very quickly that is necessary for a problem. So let's look at another one. If I was to make the statement like bracket -1, 0 bracket. Well, what does this mean in realistic terms? Well, this means all numbers between -1 and 0, including -1 and 0. And so, think about how much words this takes up, how much space this takes up on a page compared to this. And yet they have the same intrinsic meaning. We start at -1, we end at 0, -1 is included, 0 is included. So you can read any one of these statements and get that solution. And interval notation is preferred because even set notation is a lot. Like to write this exact same statement in set notation, we write -1 less than or equal to x less than or equal to 0. And so these have the exact same meaning, but one is faster and easier to write. And it's much faster and easier if you have to type. Set notation is awful if you're typing, because if you try to type this statement into Word, it won't work unless you use the equation editor, which is useful, but if you haven't used it before, it's weird. Whereas this is much easier to type. There's buttons on your keyboard for this. There's buttons on your phones that'll do every part of this. And so interval notation is amazing for being able to figure out how to write a statement like this. Now, the other option you can have when you talk about interval notation, let's do one more of these where we don't include something. What if I wrote the statement like between 4 and infinity? Okay. Well, what do each of these look like? Well, from over here, let's write it in set notation. In set notation, this will be written as x is greater than 4. And so these two are the same statement. Notice that the 4 is not included, but everything bigger than 4 is included. Notice we don't even bother with infinity in this case. Now, we could write this as 4 less than x less than infinity, but that's really uncommon. This is option, right? It means the same thing. But what does this mean in real world? This is all numbers greater than 4, not including. And so, a few things to note about interval notation. You will always see infinities with parentheses. This is because infinity is not a known value. To put this another way, infinity is an idea. We can point to 4 crayons. We can point to $0. I can point to my wallet for that. We can point to 5 cups. And even like -3 makes sense if you think of taking something away. So I could say if I lost $3 versus gaining $5. You know, I lost one friend versus gaining no friends, you know. But infinity doesn't really work that way. Like, you can't point to an infinite number of things. Like, because it just doesn't exist. It's not a real thing. Infinity in the real world isn't a real thing. Like, we talk about space being infinite, but that's just a concept. We don't actually know for a fact that it is infinite. Like, it could keep going on forever, or it could just stop outside of our range of perception, because we can only see so far. And so, like, people used to think of the surface of the world as infinite, but it's not. Like, everything dealing with infinity is dealing with an unknown. And so we can't get to infinity because this says included, meaning we get there, we get a number. We don't get infinity, we get near it, we get towards it. We don't get to negative infinity, we get close to it. And so anytime you talk about infinity, you need to make sure to use the appropriate symbol. And note that interval instant notation conveys lots of information very briefly, right? All real numbers, right? We can use a symbol that means all real numbers. It's very easy to write. We can use these notations for all real numbers. But it just means that every number is acceptable because every number between negative infinity and positive infinity is allowed. Remember, the left number is the lowest value, the right number is the highest value. And so if negative infinity is lowest and infinity is the highest, then everything in between is good. If -3 is lowest and 5 is the highest, but not including -3, then anything in between works. So -2 works. -1 works. 0 works. 1 works. 2 works. 3 works. 4 works. Even 5 would work, but -3 doesn't. Any fraction in between these two numbers works. Any decimal that is in between these two numbers works. And that same information is conveyed with this statement, right? It says that every number that exists between -3 and +5, not including -3, is an acceptable answer. It's good. Now, there's one more thing that can happen with interval and set notation. It's that if there's like a split, a break. So let me write this out. So from 1 to 3, and from 5 to 10. What this statement means in real English would be all numbers between 1 and 3, not inclusive, and, use my little symbol for and there, all numbers between 5 and 10, not inclusive. So this statement just means I can have anything between 1 and 3, just not 1 and not 3, and anything between 5 and 10. This little symbol is called a union. And what it means is and. It means they're both. So over here, same basic concept, but to write this one, it's harder. So 1 is less than x is less than 3, and 5 less than x less than 10. And so, like, you can see, like, why interval notation is so popular amongst mathematicians is because they'd rather write this, which is much shorter and faster, than write that. You can even use a keyboard and just use the U key right here, and somebody that's looking at it will get it. They get what you're trying to say. And so interval notation allows us to write statements that are mathematical in nature and get a lot of information without needing to make a big list and without needing to, like, do anything major extra. So let me look at and show you something like an example you'd see. So we're going to talk about domain and range next time. I'm not going to get into it today, but I will showcase something real quick of how this is used quite often. Let me put up a graph. Ooh, that's nice. Ooh, that's really nice. All right, let's look at a graph. So let's say This would be your standard parabola, right? This standard parabola is pretty nifty, looks great. It's got little arrows in the end, make sure those are nice and visible. Let's talk domain. The definition of domain, sorry, I went too enough, is all acceptable inputs. Or in the case of this picture, all acceptable x values. What that means is every single point on this graph has both an x and a y value. So are there any places where there isn't an x value that works? So like, is there a place in this graph where if I plug in, 6, 6, would I eventually get to a graphing point? If I plug in 6, do I get a graphing point? And in this case, like you can see that if I plug in 6, it's going to be somewhere like up here. How the graph is trending, it's going to be somewhere up here. But it exists. And so in this example, we would say that the domain is all real numbers, or we'd say an interval notation from negative infinity to infinity. Like, this is how we write that all those values are acceptable, but in mathematical terms, a mathematical statement. Because in this case, every x value is acceptable. There's no, places where I don't get an x. And so you can see, if I take my x-axis and pick a number, and I extend either up or down, I will eventually touch the graph. Like, for example, if I choose -1 as my value, right? If I choose -1 and I extend up or down, I will eventually touch the graph. And so that's, if I'm honest, that's how I always think of it. Like, x giving us a y. So if I pick -1, do I get a y value? In this case, yeah, I get -1 as a y value. If I pick, -3, do I get a value? Yes, I get +5, right? So I picked an x, do I get a y? Range is kind of the other way. If this is all acceptable outputs, or y values, in this case, if I pick a y, is there an x? And if you look at this picture, you can clearly see that there isn't for every y. Like, let's say if I chose 0. If I chose 0 for y, this point right here has an x with a y of 0. This point right here has an x with a y of 0. If I choose the point 3, yes, this point right here has an x value with a y of 3. This point right here has an x value with a y of 3. But if I choose something like -4 and try to go left or right, I never touch the graph. And so this tells me that this is a time when y cannot equal -4. Because if I choose y as -4, there is no x value that I can get out of it. There's no x that is a point. If I choose -4, if I go to the left, I never get to the graph. If I go to the right, I never get to the graph. And remember, these arrows are continuing upwards. So if I chose 10, which would be, up here, if I chose 10, yeah, I'll eventually get a point out of this, right? It was somewhere over here, and another one was somewhere over there. How many doesn't really matter when asked about the range. The question is do I get an x? Do I get an output with this input? And the answer is no, down here. Like if I choose -4, it doesn't work. If I choose -5, it doesn't work. If I choose -3, it doesn't work. In fact, it starts working when we get to -2. At -2, I start getting answers. Right? At -2, I have an x value of 0. At -1, I have x values of -1 and +1. But I start getting answers starting at -2, and then every value that is bigger than that, I get answers. Or I could write it as from -2 to infinity, but we include -2. Because at -2, I do get an x value. I get an x value of 0. We are so used to, in mathematics, thinking of X and Y as separate ideas, but they are linked, right? X's generate Y's, but Y's can also evaluate X's. They can go backwards and forwards. We're just used to doing it one way. And in calculus, you have to look and see it both ways. You have to look at this picture and say, okay, if my X is 1, what's my Y? -1. But I can also ask the question, well, what happens if my Y is 2? Well, when Y is 2, then my X's are here and here. I can get those answers by looking at the graph and estimating. And so the domain asks the question, hey, are there any X's where there's a gap in the Y's? And the range asks, are there any Y's where there's a gap in the X's? And in this case, yeah, down here, I will never get to touch the graph. It just never happens. So this is why we talk about set and interval notation. We don't talk about it by itself, because by itself, set and interval notation is not very important, right? We could always just make do with words. But in this picture, like, this statement, these two, like, summarizes this graph. Because watch how we could talk about this graph in real words. In this graph, every X value has a Y. Well, that's just what domain says right here. In this graph, every X has a Y. Meaning if I choose -5 over here, there's a Y up there somewhere. If I choose -20, way to the left, there's going to be a Y somewhere up there. If I choose 0, there's a Y right there. If I choose 2, there's a Y right there. If I choose 5, there's a Y up there. If I choose a billion, right? If I keep going to the right, that means that it's going to be up there somewhere, but it's there. It exists. Every X has a Y, so every X is an answer. All real numbers. Any number between -infinity and +infinity is an acceptable answer. But look at this graph again, and let me ask you about the Y's. You know, what's the lowest possible Y? -2. Is it included? Yes, because it's right there. When Y is -2, it's a dot on the graph, and it's included. What's the highest possible Y? Well, off the page, infinity. Can we include infinity? Never. And so we don't talk about set and interval notation enough, in my opinion, because it's a tool to be used rather than actually all that useful by itself. It's like, it's not cool when you're in high school to own a tire unless you own the car that goes with it. Well, in math, it's not cool to be like, oh, I know set notation, unless you understand that set notation is going to apply to other things like domain and range. And we will discuss domain and range in detail and do numerous examples next time with this idea in mind. But we can't talk about domain and range unless you understand what set notation really means and how it relates back to stuff that really exists. Real world sentences, real world information. When you look at this picture, we can talk about the domain and range by saying, hey, every X exists. Or we could just say capital R script. Hey, starting at -2 and going up, we have Y values. Or we could just write bracket -2, infinity. It's a way of talking about it that summarizes the information in as short a statement as possible. If you already know both these, next time it's going to be nice and easy for you, because all you have to do is then just be able to apply it to domain and range. If you don't, it makes it harder to talk about domain and range, because now you're learning two things at once. You're uncomfortable with talking about, inputs and outputs, and having to write it this way. So make sure you look at set notation. There are numerous resources out there to help assist you with learning how to write in set notation and interval notation. Make sure you look at those. They're really, really helpful. Okay? I'll even include some in the link whenever I post this onto the video. So please, please, please take a look at it, and I will see you guys tomorrow. Nice short video today, no homework. We'll look at domain and range tomorrow. All right.